Hello, welcome to the studio review for the Chapter 8 studio on interfaces and polymorphism. This one's called Spinning the Disks, and the idea is that we can kind of start by thinking about how CDs and DVDs are in some ways the same, but in other ways different from each other. And so we want to think about, what do those things have in common that we can maybe have a class that would allow them to inherit some of those same things, and what types of things would we want to maybe handle through an interface because there are just behaviors that are similar. So they talk about some of those behaviors here that you want to consider as you are designing your classes and interface. CVDs and DVDs both spin, they store data. You write disks to them. You can read the data from the disks. You can get information from them, like their name, their capacity, their contents, their disk type. So you can think through how you might have some methods, which is, how we code behaviors through methods, not properties. So that's kind of the business of interfaces, is just handling the behavior of the methods. So we'll think about that. And then you also want to think about things that are specific to classes that you might have come through behavior, through inheritance. That's what I'm trying to say. And then you can code this interface. They suggest the name optical disk as a starting point, which would make sense for just a CD and DVD, if that's as far as you're going. That's the main part of the assignment, is just having an abstract class for both of them, to have some things that they can inherit together, and then having your interface to handle some of the shared behaviors. And then you can complete all of that, tie it all together, and test some things out in your main method in the main class. So let's look at the initial code, and then we'll talk about these bonus missions for a second. You can see in the starter code in your Java Web Dev projects repository, here in the interfaces package, in the studio directory here, you've got CD, DVD, and main. So main just says, declare and initialize a CD and a DVD object, call each of their methods to verify that they work. So you're just going to kind of use that just to test them out. So the CD class here, it says, implement your interface, determine which fields, methods, and constructors can be extended from the base class and which ones needed to be declared separately. And then you're going to do the same process for DVD, depending on what things they have in common and what things they are, going to have that are unique. So this is a lot to think about already. But before you, stop and start, thinking this through and using a piece of paper or, a diagramming tool like FigJam or something like that to come up with your design, let's talk about the bonus classes, because here's the thing. If you're going to do these bonus missions, they have 4 more classes that you could potentially add here. The first 2 are vinyl records and floppy disks. And then the other ones are wheels and frisbees. So think about this for a second. Vinyl records and floppy disks are other types of media. They have some things in common with CDs and DVDs, and they have some things that are different. They have things that are different from each other. And your interface that you might have designed just for CD and DVD may not work for, one or both of these. You may need to modify some things there. What about your abstract class? Is that going to apply to everything, or do you need a second abstract class? What about wheels and frisbees, right? Okay, so these are not even media. They don't store files. There's a lot of things about them that are very, very different, but there are some things that are the same. So, is there a way for you to maybe define them a little bit differently, and still have some things in common from the base disk class that is kind of the granddaddy of all the inherited classes and subclasses. The one last thing I would think is an issue question, and this is the question that I wanted to answer with my solution, is, are there things that a wheel and or a frisbee might have in common with one of the media things but not with the rest of them, because that's where interfaces are really super useful. You might have some things that are very, very different otherwise. They don't inherit the same things, but they have behavior in common. So if you want to pursue this and you want to try to take a stab at it yourself, take some extra time to think about this ahead of time, because you might end up designing the things just for the first part, for the CD and DVD part, differently when you're thinking ahead to how it might fit in with all of these other requirements, because some of these things are just so different. But it might also make it clearer to help you think through, like, okay, what do they really have in common? And that's where you might be able to start to really separate what you're going to put in abstract classes, what you're going to put in interfaces, etc. So pause the video if you need to sit down and work on all of this for as much as you plan to design for yourself. And then in just a second here, I will show you what I came up with, and we will go from there. I will code it for you. Okay, so initially, I kind of came up with, for just, not counting the bonus missions, but with some thought about the bonus missions in mind, I came up with this sort of arrangement that you would have your base disk, and it would take care of all the things like, tracking an ID number for each object, everything having a name of one sort or another. What kind of disk is it? You can define that however you want, but it would kind of help you have a way to store some information that can be useful, especially when you need to modify your toString method and you just need to say what type it is. You could have a way to store that. And then the spin rate, if everything spins, if that's what we're talking about, or things that spin as a disk, then that's going to be something that anything would have in common, not just CD and DVD. So it's like, okay, I've got that. And then of course there's a constructor for the three things that are not IDs. And then have a custom toString and have the spin disk. Now in the instructions, they kind of have spin disk as something you might put in an interface. As I worked on this, I decided that I wanted my interface to handle some other aspects of things and not just the general spin, because that really could apply to just about anything. So I'm going to keep that here. And then there are some things that I thought about that CD and DVD had in common, but I ended up not putting them in here because if I'm going to use this ultimately down the road for things like a wheel and a Frisbee, I can't, if they're associated with CD and DVD's identities as media, then I need to have them separate. So I decided I'm going to have my base class here that's abstract, and then I'm going to have another abstract class that handles just the media aspect of things, like what's the capacity, what's the list of files that it holds, and then of course if we want to get a formatted list of those to put in with a toString, let's have a way to put that together. What if we want to check and see if a file is present before we try to do something? How much space is still available? How much space is used? So those are all things that will work for any type of media. And then I'm leaving to the interface over here this idea of something being rewritable, that you can have something that will let you, add and remove files at will. So I've got these methods here: write file, remove file, reformat disk, which basically just means wipe it completely, and then run file to run an individual file. And those things definitely are behaviors, which is what interfaces are meant to require, that CDs and DVDs have in common. So for now, I'll just apply that to both of them. But I wouldn't necessarily apply it to all media, because again, I'm thinking ahead about the bonus missions. And if vinyl record is a media and it has all these things that'll work, but it's not rewritable, then I can't apply these behaviors to that. So that's why I'm going to keep this interface separate from the things that a vinyl record might inherit from media through class inheritance. So this is where these things start to kind of separate, right? with CD, the one thing I added here was is music CD as a way to kind of, because you can have music CDs that you just like plug in and play, that are formatted a specific way, and then you know, with tracks, right? And then you can have you know, CD-ROMs or CD, you know, read writable that allow you to just store files in the same way that you store them like on a floppy disk or something like that. DVDs, on the other hand, you know, they're plug and play, and you can add a bunch of files to, you know, have all the videos that will compose the DVD, but that's probably about it. So it's going to have some things that are slightly different, but it'll still make use of all these behaviors over here. So that's kind of where we started. Now, the one thing I haven't mentioned is this file class over here. You may have noticed this. In order to be able to associate a name and a size together with all the individual files that you might want to store on one of the media objects, I decided to have a class to hold those two pieces of information together. So that's all this does. It's just basically saying, let's just pair up names and sizes that we can then collect, you know, and define a bunch of those, put them in a list, and then we can work with it from there to, you know, add them to the different types of media, remove them, play them, you know, all that sort of thing. So this is where I'm going to start, and then we are going to move into the other classes, the other 4 classes that are mentioned in the bonus missions, and really start to unpack this further. I'm going to have yet another interface that will tie some other things together that definitely do not have the same inheritance path. So it's going to get interesting, guys. It's going to get interesting, and this is going to be a long one. Again, like last week, this is a very ambitious studio, especially once you throw in the bonus missions. So buckle up. Here we go. Let's go ahead and take a look over here at these classes. So we've established that we've got, you know, 3 files that they gave us, but we need some other ones, right? So let's create a new class, base disk. And then I said I was also going to have another abstract class that I wanted to have called media, that's going to grab things from base disk, but then define some things of its own to pass down to CD and DVD. And then I need my file class in order to compose a list of files for any type of media object. So we'll call this file. All right, and then the last thing is that we said we were going to have an interface. So I'm going to change this to interface here, and we'll call this rewritable. The original class that they suggest in the instructions was optical disk, but once I realized that I was going to apply this to one of the other ones in the bonus mission, I decided to call it rewritable instead. To make it a little more clear exactly what it is I'm defining. Okay, so I don't want to start with the interface. I actually want to start with base disk. Let's get some of the stuff that, you know, belongs to everything down. And we did say we want this to be abstract. So I'm going to make that abstract. And now we can, you know, start going through and using some of the things that are on our diagram here, and just getting the actual code down, right? So we'll have a private static int. So this is where we're storing this ID number, the next ID number to be assigned at the class level. That's what static does for us. So it's not stored at an object level. And then every time we instantiate a new object, we will have this final ID that is assigned from this, but then we will increment this up so that the next object created will have a higher number. All right, so we need a string name. Oops. We need a string disk type, and we need an int spin rate. That's going to be in RPMs. RPMs. Okay. So we can create a constructor from this, and the constructor itself is going to have, I can go ahead and add these. I'm gonna modify this. We're not going to actually have ID is a parameter because we are going to assign it from next ID instead up here. And then what we want to do is before we close out this constructor, we want to increment next ID up so that again, the next time an object is created from this class, it'll have a new number to draw from at that class level. Okay, so we got a constructor. Let's do some getters and setters. We need getters only for next ID and ID. And then for name and disk type and spin rate, we can do getters and setters. There are going to be reasons later why we're going to want to be able to have setters on some of these. And sometimes we're also going to override some of these for very specific reasons down what am I trying to say? down the lane, down the bike, something like that. Okay, you can tell I'm tired. Probably not going to be the last time I do something goofy. Okay. Okay, so the next thing on the list is to override toString. So I'm going to come here and we're just going to say, yeah, we want to override toString. And we're going to start off with, I'm going to create a new line character. You're going to see me do this a lot. I am choosing to model it this way just because it's what Launch Code wants you to use for your graded assignment number 2. So I'm going to continue to use this method of creating a new line character instead of the \n. And I'm going to have this other little thing that because I'm going to use it a couple times. I'm just going to say asterisks. And I'm going to have this little, line of asterisks here that I can use so that when I return what I want to return, I can kind of format it the way I want. So I'm going to say new line plus asterisks plus a space plus the name. So I'm just going to put the name in between these other characters to kind of form up a little header before everything else prints below. And then we will print ID plus new line. Oops, there we go. Disk type. So this is, or you're going to use this toString to just display all the information about it. If you ever want to look up information about your disk, this is what you will find. And these particular things are going to apply to just about any type of disk you can imagine. So regardless of what they're used for. So let's see, spin rate. And then here I want to also add RPM to give it a unit. And then I'll add one more new line and close it out. Okay. So that's going to give us our header line with the name of the object. It's going to give us the ID, disk type, and spin rate of the object. And then later, when we have classes that inherit from base disk, we can continue building on this. We can call, super toString to get all of this and then add more information on, because some of these other classes are going to have their own information unique to them that aren't included in this abstract class. So that's one pattern of how you can use overrides on toString to your advantage when you have inheritance. And I modeled this with my lecture examples on the bookstore project too. So if you're not familiar with that, you can reference that as well. Okay, last thing is we have an instance method here, spin disk. So it's void because it's just going to print something to the console for the user to read. Again, I'm going to do the new line here so I can use it more than once. And although I may not use it more than once on this one, let's see. New line plus. All right, so I'm going to piece together a sentence here. I'm going to concatenate this. I'm going to say the disk type, no matter what it is, we'll be able to have some way to describe it that way, plus a space, plus the name, plus is spinning at, and then this is where we can say what the rate is, plus, and then we'll again use the unit RPM there to be clear about how fast it's going. Okay. So that should do it. So these are all very basic things that are going to give us a foundation for all of these other classes that we're going to be creating. So the next thing to do, obviously we're going to create media to inherit from base disk and then add some additional things. But one of those things is an array list of files. So that means we need to create our file class first so that we can then set it up here and create a list of these objects. So let's go define file, since it's kind of a small unit that's going to, compose this list. So we'll go over to the code and switch over to file here. I'm going to get these in a certain order so it's a little easier for us to manage these in a bit. All right. Yeah, let's do this here. Okay. So file is not inheriting from anything. It's kind of its own thing. But it just has a name as a string and double size. Okay. And I don't see any reason why we would ever overwrite those. So I went ahead and set them as final. So I could create the file is what it is, and we're just going to use it as it is. So we'll just have our old constructor here. And I totally could have used the generator on this, but I'm like just typing away. That's okay. I can't use the generator, oops, for the getters. Let's do getters for both of these. So we can access them as needed. And then I want to do an override on the toString so that whenever we want to get all of the information in a nice formatted way on each file, like if we want to do a list of all of them, we can have that just easily do it by just, printing the object itself, and then it'll automatically call the toString. So I'm going to say I want to do a toString here with that information, but what I really want is just to return name plus, and I'm just going to do like a little space dash space here, plus size, and then I'll add on megabytes so that we're clear that the size is in the units of megabytes. Okay, so that'll provide a little phrase there that we could print any time we print a file. That's what we'll get. Great. So this one's done, and we can go over now and start to fill out media. But of course, the first thing, there's two things we want to do here. One is that media also is going to be abstract. We're never going to create any objects directly from media. We're only going to create them from its subclasses. But we do want to extend base disk because we want to start with everything base disk has to offer and build on it from there. Now this red squiggly line you're seeing, it says there's no default constructor available in base disk, which is true. If we come over, we have a defined constructor, which means you're required now to define a constructor here. But let's take it one step at a time, because first we have a couple of fields to create. We've got capacity, that's a double, and files, that's an array list of file objects. So let's create those here. So I'm going to say private double capacity, and then private final array list file. So this, remember that when you have, there we go. When you have final on a collection, like an array list, it just means that the entire list can't be overwritten. It does not mean that you can't add and remove files from it. We will be able to do that just fine. Okay, so now that I've done that, I can create a constructor for this thing. And I do want to include capacity. So we're going to say that we're going to pass down name, disk type, spin rate, and capacity We're going to require those for, and then we can pass the first three into the super constructor, which is, the constructor that's defined in base disk. And then because capacity is defined here, we set it directly here from this parameter that's passed in. So that is, part of the inheritance syntax that's required. And then we just need, let's see, a getter and a setter for capacity. So I'll do getter and setter for both of them. And then for the array list, I'm going to do a getter, but not a setter, because we are going to not really provide for a way for files to be added to the array list, except through our rewritable interface where we have something like write file here. That's how we're going to be able to update this array list. Okay, so getters, setters, good. Now we can do our override on our toString. And what I really want to do here is I want to start with the toString that's coming from the base class and then add to it. This again is this pattern that I want to follow where we're just building on it. So here we're going to have some lines that look a lot like the lines that were in base disk. We can, in fact, borrow from one of them. I'm also going to need to borrow this actually as well. Let's do that because we're going to continue to use this new line thing over and over again. But we can do something just like this for each of our additional properties that we want to provide for. So let's see. So we've got capacity. And so we'll say capacity, and then I'm going to add megabytes. Oops, plus sign here. There we go. And then there's actually two more things I want to do. I want to do space used and available space. But that means we have to actually have a way to calculate that. And so we've got a couple of instance methods down here we're going to need to define in order to provide for those values. So let's put a pin in this for a second. Actually, let me undo that. I'm going to just stop it right there. We'll come back to it. All right, let's, we've got a formatted file list, file is present, get space used, and get space available. Let's define the next one. So for formatted file list, this is one of those ones where you're saying, okay, I have a whole list. We have an array list of file objects, and we want to go through and loop through them one at a time, and then find a nice way to format them so they'll look good when we print them out in the console. I'm also going to provide here this header that basically means we can customize no matter how this is used in different subclasses. We can customize what that header says that we put at the top of the list, and we can just pass that in as a string. So to build the rest of it, we're going to need a string builder. So we've got, the string builder class from Java, and I'm going to just call this file list, and we're going to say it's a new string builder object. Okay. I'm also going to put in the string new line. You're going to see a whole lot of this, guys. All right, and then we can loop through. But only if we actually have files. Otherwise, there's no point in doing it, right? So if files.size is greater than 0, we will create this header. We're not going to create the header unless we have files. So we'll take our string builder, and the first things we append are a new line and that header that's been passed in. And then I want to append a colon. And that's going to be it for that first line. And then we're going to loop through and continue to add to it. So we'll say for each file object out of the files here, which comes, directly from the class. It's this field up here, files, the array list. For each one of these, take the file list, string builder object, append a new line, and then append a tab. So \T, it's another one of those escape characters. And then we'll append the file itself. Now, you might be saying, but file is an object. Well, that's exactly why in the file class, we defined an overridden definition for toString so that we could say, this is exactly how I want the information on this file to be displayed. And then anytime in Java, when you go to stringify an object, it's going to call that toString method. And if you have defined it the way you want it, it'll look exactly the way you want it. So we're going to take advantage of that here. Okay, so we could just do that over and over again for every single one of the files and get a whole list of those with the name and the size. And then after all that's done, we can return the string builder object, but we have to convert it back to a string. Okay, just like that. And that will get us a nice formatted file list to be able to print whenever we need it. Okay, next one is a Boolean. This is going to be a way for us to provide a little bit of validation. We're just going to check at any time, we'll check the file list to see if a file is present before we do, go to do something like, run it or erase it or whatever. So instead of, okay. I'm getting ahead of myself. If, and then we can use the getter for get files since we are now in a subclass. We can't access files directly. If it contains the file in question, then we will return true. But I'm not using a ternary for this because I have something else I want to do if it's false. I want to print a message here if it's false and say that file does not exist on this, and then I can concatenate here with get disk type so that it'll say whatever it is, CD, DVD, whatever it is. And then I can just put a period on the end. But that way we have a little bit of feedback to the user that just lets them know what's going on. And we're doing it here so that we don't have to do it in several other places anytime we're checking to see if the file is there. And then we can return false. All right. So that'll take care of that. And you'll see in the future as we really dig into things where that's going to become useful. We're really just laying a lot of groundwork right now. All right. So we're going to do the next one, which is get space used. We're going to calculate how much space has been used by the files that are currently part of the file list. So we'll use our accumulator pattern here to start with a 0 and build a total by looping through file of files and just say take the total and tack on file.getSize. So we go into that file object that's defined over here in the file class and just use the getter for size to find out what its size is. And that provides us with that number. And we'll just keep adding it on until we have the total. And once we do, we can return the total. Okay. And then the last one, of course, is to get the space available. And that's where we compare the space used against the capacity. So this one's also going to return that double. And we'll say get space available. And we'll say if the capacity is 0, return 0. Which actually, I don't think that's necessary anymore. I think I changed my mind about the way I designed one of the classes, but I'll leave it. It's okay. It doesn't hurt anything. But what we really are interested in is return capacity minus get space used. Okay. So that will allow us to, make use of this one and the capacity that's being saved up here as one of the fields of this class, and do the math and let us know how much space is still available. And then we can come back here to our toString and finish it. Because we can add a couple of lines here that basically are going to say, space used, and we can say get space used, and then available space, get available space, or get space available, I guess is what I called it. There we go. And then of course, those are all measured in megabytes, so we can leave that there. And that's 3 more lines now that'll be added to our list of information on top of the things that are being inherited from the toString that's defined in the base class. Okay. That's it. Okay, so that was a lot, but this is, we're building a foundation here for all of the things that we're going to take advantage of all these things with these classes. And these are the ones we're actually going to create objects of. Next here, let's go ahead and do CD and DVD. And then we're going to fulfill the contract of this interface over here. We'll implement the interface on each of these and then give them unique definitions for each of these 4 that allows them to define very specifically for themselves what that behavior looks like, but they'll have that exact same signature, and it requires that they have all 4 of them when you implement that interface. Okay, so let's do CD. I'm right over here. And before we get to the interface, I'm going to just say, extends media, right? Because this is definitely a media type object in addition to being a disk. So we're going to inherit everything from base disk and media by extending media. All right. And then we have one more unique field to add here, is music CD, because there's going to be some ways in which we're going to want to do things a little bit differently depending on which type of CD it is. So this is an easy way to keep track of that. Okay. Okay, so I can do a constructor here and make sure I include this. Now, here's the thing. We can actually simplify this if we have some of these values that we know are going to be constant for a CD. So for example, I really only need, when I create an object of CD, I only need to know the name and whether it's a music CD or not, because all 3 of these others, disk type, spin rate, and capacity, I'm going to just pass in values for. So we're going to hold on assigning the disk type. Good heavens, there we go. And do it in just a second, because we're going to set the disk type based on whether it's a music CD or not. But we can't do that when we call super, because we haven't even done any of this yet, right? We have to create the object first. But we're going to say that the spin rate is 800 RPMs. We're going to say that the capacity is 700. And we're just going to say that those are constant. They're not always, but for simplicity's sake, we will say that it's those are constant rates. And this is a constant capacity. So we'll set that. And then we will set the disk type using set disk type from, we're inheriting all the way from here. That's just the setter for that field. And we'll say, okay, it's going to have one of 2 values. We're going to ask, is music CD true? And if it is, we'll say this is a music CD. And if it's not, we'll say it's a CD RW. All right. So that's going to give us some text to use that'll be handy when we're, having descriptions of things that print out in the console. And it's the appropriate text depending on whether this is that type of CD or not. All right. So we this is just an easy way to temporarily give it something blank and then overwrite it with one of these 2 values after this has been set and the item has been instantiated. It's just, you have to do things in a certain order. So this will work. All right, then we need one more constructor, because what I would like to do here is to make it possible to just default that is music CD value to false, so that you only give a name. And if you do that, it means that it's automatically, you're saying it's not a music CD. It's actually just a CD RW. So all we have to do for this is say, call the constructor right here, pass in the name that you're pulling in from here. And then for the second parameter is music CD, give it false. And that way we have a default for that and only have to pass in the one. So it'll give us some flexibility on how we create objects of this class. All right, so now we need a getter and setter for is music CD. Let's do that. And then we want to override toString. Okay. So I'm going to use, I'm going to actually use the override here, toString. So it's going to start us off with returning super.toString. But the thing is, I've got two different potential headers that I could have here before we get that formatted file list. So I'm going to say string header, and I'm going to ask that question again. Is this a music CD? If it is, I want the header to be tracks. And if it's not, I want the header to be files. And now, in addition to calling the super.toString, I can say get formatted file list and pass in that header. And that way it'll present that list of all the files, and the header will have either tracks or files in it, whichever makes the most sense for this type of CD. All right. So now we get down to methods required by rewritable, and we have not implemented rewritable yet. So we're going to need to do that. So let's go back over to here and look at rewritable. We need to actually have this defined first, and we don't as of yet, but we know we want write file, remove file, reformat disk, and run file. They're all void, and reformat disk is the only one where we're not passing in a file. So this is going to be pretty straightforward. Remember that with interfaces, they are automatically abstract and they're automatically public when you just provide the signature like this. So that's all I have to do is just say void. This is what I want you to name it. Got a return type of void. This is the name. This is the parameter and its type. And that's it. No body. The body is to be defined in the actual class that's implementing this interface. And then this one doesn't have a parameter, but our last one does. Run file, file, file. All right, that's it. That's all we need. Interfaces are nice and clean most of the time, because you really just have, you know, that bare bones instruction for just require these, don't define them, just require them. And that's usually what's going on there. Okay, so we're going to flip back over then to CD and say implements rewritable. And as soon as I do that, you'll notice this turns red again. It says class CD must either be declared abstract or implement abstract method write file and rewritable. So already it says there's at least one method that you have not implemented that's required by rewritable. So that's where we come down here, and I'm going to use the generator in IntelliJ and come down here to implement methods. And this is the quickest way to get that list. These are the 4 that are required. I'm going to say okay. And then it's going to go ahead and provide those signatures and open bodies. And all I have to do is fill in the code that goes between the brackets. So we'll come back and think about this. Okay, so for write file, and these are going to be a little bit involved, but I'm going to talk you through it so you understand the logic, kind of what we want to accomplish here. Because, you know, right now I can show you the, you know, kind of the outline of everything here, but all we know is this is required. I haven't really explained to you what I intend to do with these, right? the very first thing that I want to do anytime I do something that would cause the disk to spin is to spin the disk. So we have that spin disk method that was defined in base disk. So I can, and all, if you remember, all that does is print out the disk type name is spinning at spin rate RPM. So it'll just, fill in the blanks there with the appropriate information and print that before it does anything else. So it just tells us, it lets us know, okay, it's up and spinning, and then we're going to tell it what else to do. So we'll spin it, and then because this is a CD, I'm going to define file type to be either track or file, because here again we have two different types of CDs possible. And then we can use this in our little feedback to the user. So the first thing I want to do is check to see if the file has already been added, because if it's already been added, we don't need to add it, right? So I'll say if, and I'll access the files array list using the getter, get files contains, and that's just a method of array list, right? And if it contains that file already, then let's just print something out, and we're not going to do anything else. We'll just say the file type and have a space, and then have the file.getName. So that's the name of the file, not the name of the CD. Has already been added. Okay, so we have gone ahead and taken care of that kind of validation. The second validation is, what if the disk is already full and there's not enough room, right? We need to think about that. So we're going to check for that next. So we'll say get space used. If get space used plus file.getSize would end up exceeding the capacity. So we're just going to check the math before we actually do anything. What if we were to add this file at this size? What would happen? And we'll say if that's true, then we're just going to print a little warning here. Warning, there is not enough space on the, and this I'm going to add, get disk type, so we can get the specific terminology for that. And then for file.getName, and we'll get the name of the file there and make it part of the sentence. And we really could add a period there. Okay, so that'll take care of that, because we'll just warn and say, nope, can't do it. We cannot write it. But if we pass both of those checks, if it isn't already there, and if there is room, then we're good to go. So we're going to say else, get files, access the list, oops, and now use the array list method add to add the file. And then we'll print a confirmation. And this is where I'm going to use my custom file type here that says either track or file. The file type, and I'll give it its name, so file.getName, has been added to, and then I'll get the name of the CD and add a period. Okay. So we're covering a lot of bases, but this is, it's important to be thorough. It's good to think these things through and make sure that you are, preventing things that aren't possible. Okay, so remove file, we're going to have that first check is, if it's a music CD, we can't really just go and remove it. It's not the same as having a read writable. So I'm going to say, if it is a music CD, we're just going to print a message that says individual, spell it right, individual. Files cannot be removed from a music CD once written. But But if that's not true, then we will spin the disk so we can get it up and running. And then we will check to see if the file is present. Now, this is that method we wrote so that we could use it wherever we needed it. That's just checking for the file. And by the way, there's a reason why I didn't use this here. And that's just because I wanted to have a different way of saying this because of this file type, than to use the default message that we already put in file is present. So that's the only reason I didn't use file is present up there. It was a conscious choice. But here, I'm just going to let it, if it turns out that the file is not present, I'm going to let that message that exists inside, oh, that's in media, hang on. I'm going to let this message that's inside this here just go ahead and print that instead. Okay. Back to CD. Here we go. If the file is present and I have to give it the file, then get files, access the list with the getter, and then say remove. Remove is an array list method. And I will just say remove that file and it'll take it out of the list for us. Okay. And in my solution, I did not actually put something here, but I think we should have some sort of statement that says the file, yeah, let's just say the file, and then file.getName has been removed from the get disk type. Okay. And that way we got a confirmation there. That really is best to always kind of give feedback once you take an action like that happens behind the scenes. Okay. Reformatting disk. This is going to be pretty straightforward. You want me to wipe the disk? I'll wipe the disk. We're going to spin it. We're going to get the files, get access to that list, and use the array list method clear, which just says, okay, take it back to basics. We're going to have an empty list now. And then because if we had, and we don't really need to check because this will work either way, but if we had a music CD, if we're actually reformatting the disk, then we are actually changing this from a music CD back into something that's writable. So I'm going to say set music CD false, which is that is music CD. It's the setter for is music CD. And then set disk type, and we're going to change it to CD-RW so that it's no longer a music CD. And that way it's now available as something that can be written. And really we could go a step further if we wanted to, and we could also say set name and say unnamed, I don't know, unnamed CD RW or something like that, so that it no longer has the name that the CD used to have or something. I don't know. That's up to you. That's kind of a little thing. All right, last one, run file. So this one, again, is going to have a little bit more. Really, all we have to do is check and see if it's there, right? If file present, file is present, and give it the file to check. Then we can spin the disk. We can choose a custom verb depending on whether this is a music CD or not. And we'll say playing, or we'll say opening file, because, two different types of disks, right? And we'll say verb plus file dot get name plus ... So we're just going to have a little bit of, okay, we're playing this file or we're opening this file. And that will just, again, give that feedback to the user that we have initiated the request. All right, so we have written very custom definitions for all 4 of these behaviors that were required by rewritable. Now we get to go over to DVD and do a similar but slightly different process. All right, so with DVD, we don't have any additional fields to add. All we need to do is customize the toString and customize, implement rewritable and customize these. So we do want to start by extending media. We can go ahead and say implements rewritable. We're going to do it all. So we'll start there. And now we have a number of things to do here. So the first thing is the constructor. Now I thought about this, and similar to what we did with DVD, we really don't need to explicitly state these because we're going to say that they have standard values. So all we're going to require when you create a DVD is to give us the name. And then when we use the constructor that's defined in media, we can give a name, but then we can also say, it's always going to have a disk type of DVD. It's always going to have a spin rate of 1200 because again, we're just going to generalize. And then we'll say that the capacity is 4700 megabytes. Why not? Okay. So that way we can just kind of use hard-coded values for those. And the only thing we have to provide is the name. Could you provide additional information for a DVD? Absolutely. Maybe there's, I don't know, you could go crazy with production company and starring actors and, lots of things, but we're going to keep it simple on that score. We'll override toString. So we'll come here, choose toString, and it's going to give us super, and then we're just going to tack on that get formatted files file list that we defined in media. And for the header, we'll call it video files. And that way it'll start off the list with video files and then list them each individually after that. Okay, so that's the customization for that. And now we need to do methods required by rewritable. So this is where I'm going to use implement methods. Say, yes, I need all 4 of those, please. And then we're going to do something similar. And honestly, let's see. Yeah, we can probably borrow from here and then just customize it a little bit. So I'm going to borrow from CD because it's going to start off similarly. We don't need to specify a file type here because a DVD is a DVD is a DVD as far as our program is concerned. And so instead, I'm just going to take out all of that extra there and just say the video and then file.getName has already been added. And then here, we're going to do the same formula, check the space used with the potential size of this file against the capacity. And then we can warn, and yeah, all this part's the same. And then here, again, I can just replace this and just say the video because I don't need to have different words. And yeah, so that's all the customization I needed here for DVDs. And then for this one, we can really just take this. We don't need to check and see if it's a music CD. So let's start here. And we'll spin the disk. If the file is present, remove the file and then, and then confirm that it's been done. Okay, override, reformat, yeah. Reformatting is simpler because the only things we're changing, we don't have to worry about the music CD stuff. So we're just gonna say spin disk and then get all files and clear. So put that in here. And then for this one, it's going to be very similar. What we do here, we're going to check to make sure it's present. We're going to spin it. We do not need to have a variable verb there. We can just hard code that and say watching, because this is a video, right? Watching whatever the file is, ... Okay, so I hope this starts to help you understand how it can be really useful to make sure you've got consistency in the names and the signatures of all of these and require multiple classes to have them, but they need to have their own definition completely because there's enough details that are different. And CD and DVD are probably the most similar of all of the other classes we're going to do as we get into the bonus missions. So these were not that far off from each other, but they were a little bit. Each one was a little bit different. So that's that. Okay, so we have accomplished everything except for testing it out, right? So we can create some objects here. I'm going to, for the sake of time, because we still have so much to do, I'm going to just go ahead and copy this over and talk you through it, because we do have so much still to do. Okay, so I'm going to create a CD, the North Borders. It's a music CD, so I'm saying true. And then this CD, I'm using the other constructor that only requires a name because I want that to default to false. And this one I'm going to call Graphic Design Projects. It's just a CD RW. I gave it a name. And then I've got a DVD, Friends Season 3. Now we'll create some objects and add them to each of these discs. So I've got 3 tracks, First Fire, Cirrus, and Transit, to be added to the North Borders. And I just realized that I never provided for an artist on these CDs, but that's okay. And then after creating them, I'm using the write file method to add each of them. Remember I said that we weren't going to have like a setter or another add to files, thing. We're going to make sure it was this write file that took care of that for us. And then I'll have a festival poster, a Photoshop file, and company logo. I'll have a Illustrator file that we're going to add to this Graphic Design Projects CD RW. And then I have 4 episodes, the first 4 episodes of Friends Season 3, the one with the Princess Leia fantasy, etc. And we're going to write each of those to Friends Season 3, the DVD we created up here. Okay, so once we've done all of that, we've put all of the data on there, we can print those objects out. We can use run file to run specific files. So I'm going to say run Cirrus. On this one, Graphic Design Projects, let's run that company logo file. And then write the file. We're going to try to write a file to the DVD that's already been written. So Season 3, Episode 2 is already on there. We wrote it right here. What happens if we try to do it again? We're going to see that print out. Use erase data to remove a file from the CD-ROM object and then try to run that file. So I'll take the graphic design projects, and I realize I have a mistake here. Remove the file festival poster and then try to run it as if it were there. And we want to make sure that our logic is working there to catch those kinds of things. And then reformat disk. We want to wipe files from the music CD, and then try to run a file from it. So we'll reformat the disk entirely on the North Borders, and then try to run the transit file that used to be there. The last thing is to create a 720 megabyte MP4 file and try to write it to the CD that's no longer a music CD, which was the North Borders. So I'll make a file that's too big, and then try to write it, and we're going to see what happens, because we had some logic to try to test for that too, right? To make sure there's still enough capacity to write a file. So we want to try all this. Let's go ahead and give this a run. I come up here and run it, and we'll look at it bit by bit here. Okay, so let's start at the top. The music CD, the North Borders, is spinning at 800 RPM. The track First Fires has been added to the North Borders. So we're seeing one by one where each of these tracks are being added as we told it to write them to it. So now we're writing festivalposter.psd to Graphic Design Projects. We're writing companylogo.ai and so on. Here's the 4 where we were writing the episodes to each of the, to the Friends Season 3 DVD. So we've done all the writing. Here's printing it out. So this is what our toString gets us. We get these first few that came from base disk. We get capacity, space used, and available space, along with that comes from media. And then we get the formatted files where we passed in the header that comes specifically from CD. And you'll notice that it chose tracks because this was a music CD, whereas down here, this CD, it says files because this is not a music CD. And then of course on the DVD, it says video files because we, customized that as well. And we get these nice printouts of the names and the sizes from the toString that we set in the file class, to where it always prints it nicely for that file. Now we, are saying, okay, let's run the file. So we run Cirrus, and it says playing Cirrus because it's a music CD. Let's run this file, company logo. It says opening file, company logo.ai. For this one, this is where we were trying to add something that had already been added, and it tells us that's already been added. When we try here to, we remove that file, and then we try to access it again, it says it doesn't exist. Same thing here with, we cleared that other CD and then tried to access a file. And then here we actually tried to add a file that was too big. It says warning, there's not enough space. So everything we did worked out. We have, lots of validations in place to make sure that we only do things if it's possible to do them. And we're making use of things like keeping track of the capacity, right? And the type and those types of things. Okay, this is great. So we have the main part of this assignment done. Everything except for the bonus missions down here. Yeah. Okay, so I, will take a deep breath, and I'm actually going to take a break for a minute here. I'm going to pause the video, take a break, and then I'll come back and I will code all of these bonus missions for you. Okay, I am back. So let's take a look at this. So the idea here is that we want to figure out a way to also represent vinyl records, floppy disks, and then ultimately wheels and frisbees, which are not media at all. They have very, very different properties. So I have come up with another, so we started here, right? Just looking at media to represent CD and DVD separate from base disk, because the idea here is, wheel and frisbee are definitely not media, so they're going to inherit from base disk, but not from here. Vinyl record and floppy disk are media, but they've got some things about them that are different. So here's kind of what I came up with. If we want to have vinyl record, floppy disk, CD, and DVD all inherit from media, we can do that. So that's what these relationships here are represented, right? And then this rewritable interface that we already have, that we applied to CD and DVD, also applies to floppy disk. It does not apply to vinyl record. A record is pressed, it is not rewritable. So we'll use, this, take advantage of this idea of an interface to say we need these three behaviors to be defined for these three, but not for this one. So we can't use inheritance for that. That's why we're using the interface instead. Meanwhile, if you think about a frisbee and a wheel, they don't have any of the stuff that's in media. A frisbee really, we're interested in the diameter, and that'll tell us, how to calculate things properly. And then with wheel, we are also interested in its radius and how fast is the car going, because the RPM actually depends on the speed of the car. So we have a drive car, method down here. We've got a throw frisbee method up here. So we have a few things that make each of these unique. But I also recognized, what? I've got another set of behaviors that is shared by some of these, that really the only way that I can connect them is with another interface. So I've got an interface called variable RPM that is going to apply to floppy disks, because you have two different sizes of floppy disks. To vinyl record, there's three different sizes of vinyl record. And then of course, as we just said, the RPM can change with a wheel because of a wheel just based on the speed of the car. So we're going to say, let's use pi as a constant. Let's use this inches per mile constant will be useful for some of these to calculate. And then we're going to require is valid. We're going to have a very specific way. Like each of them has a very unique way of validating what it takes in order to be able to calculate the spin rate based on the different types of information that are needed. Whereas calculate spin rate will actually just do the math for us, but there again, very, very different ways of coming up with how that's calculated. And so this is going to, each of these will use different constants here. We've got some maps that have, multiple, different pieces of information, like a floppy disk. If it's a 3.5 inch disk versus a 5.25 inch disk, they're going to have different speeds. They're going to have different capacities. So we'll be able to kind of look that up by using that information. And then width is something that can be passed in so we can know when we create the object, which one is it, and then get the right values from here. And that will help us when we go to implement these methods to be able to be sure that we can do the math with the information at hand. Vinyl record, depends on the diameter of the record, and then that'll help us kind of determine which RPM it is, which I realize it's more complex than that. It's not a perfectly one-to-one relationship on the different sizes and speeds, but we're going to simplify it and say that it is that each speed has a specific diameter, and just use the most common one. And then we'll also identify an artist for the record to be able to store that information as well. And then we'll have a press vinyl method, because over here we have a write file to be able to add files to these rewritable types of media. But for this one, we just need to say, okay, well, when we're ready, we're going to add a bunch of files, and we'll do it all at once with this press vinyl method. And I just realized that, hang on a second. Yeah, I realized that this really should be updated. Let me fix this. I'll fix it right here. This should say that it's going to have a file array that is a Java array of the type file. We can pass that in to give it all of the files at once and say, and we'll validate it. We'll use this as valid to make sure that it's not too much for the capacity of the record. But then we can press it. It'll be ready. It can't be rewritten, but we can play tracks from it. So we'll have a play track, and that's going to be a little bit more in line with like the run file over here, but it'll have different terminology and whatnot. So yeah, so we've got more things we can do here, all of which ultimately do go back to base disk, but have very different categories of behavior, and some of them really do cross across the different families here of inheritance. That is where an interface is invaluable. So let's go get to work on these. We're gonna do the first two first. We'll stick with the media for now and do vinyl records and floppy disks. And then we'll actually go and start doing the non-media ones and get those under control. Okay. So we can come back over here and say, okay, we're going to need a new class called floppy disk. It's going to extend media. And you remember I said that in class, in lecture, that while you can only extend one base class, you can have multiple interfaces. Well, you may or may not have picked up on this when I was talking about it, but floppy disk actually can implement both rewritable and variable RPM. It can require all of these and require these. So we're going to do that. We're going to go ahead and implement rewritable now because it exists, but we haven't created the other one. So let's do that. Let me open this up. All right. And we'll call this one variable RPM. And this is where we're going to set these constants, pi and inches per mile. And then we're going to just give the signatures for is valid and calculate spin rate. Okay, so variable RPM is going to have a static final. Remember, this is how we do constants in Java, static final. And then this is going to be a float. And the reason that I'm making it a float and not a double is because I'm going to want to be able to round it to an integer later. And that works more easily with math.round if you have it as a float instead of a double. So float instead of double, I'll just put this note here for rounding to an integer. Okay, our other constant that we're defining in our interface is inches per mile. I'm going to use that screaming snake case there. And that number is 63,360. And that'll come in handy for us a couple times. Okay. So again, all we need to do here is say the return type, the name, and there's no parameters, and that's it. The return type, calculate spin rate. And there again, no parameters because they're just going to use fields and methods that are built into those classes. Okay, so we have ourselves a couple of things here now that can be required through variable RPM. So let's head back over to floppy disk and require it. Now here's what you do. You use the implements keyword once, and then when you're assigning multiple ones, you just use a comma like this and just give the second name. So I can just say implement rewritable and variable RPM, just like that. All right, so now we got to put it all together. So let's revisit floppy disk here. We need a map of speeds, we need a map of capacities, and then we're going to need a double width. So let's come over here and start setting these up. So private static final map, and this is going to be a key that's a double and a value that's an integer in each of the key value pairs. I'll call it speeds and say it's a hash map. But instead of, let me get this in. It looks like I need to do the same with map. Okay, there we go. Got my import statements. Okay, now you can leave it as an empty hash map like this, or you can go ahead and assign values to it with double curly braces like this, and then just use the, it allows you to go ahead and start using the methods of a hash map to put things in. So I can put lines of code in here like, I want to add for that double 3.5, and so for a 3.5 inch disc, I want to say that the RPM is 300. For a 5.25 inch disc, I want to say that the RPM is 360. Those are the most common RPMs for those particular types of media. And again, another private static final map. I'm going to do this one double, because this time we're going to be talking about capacities. So those values are doubles and not integers. All right. And then here again, I'm going to go ahead and just assign the values right here and say put for 3.5 inch, we'll go with 1.44 megabytes. And as the max, they certainly were not that high when I was in school. And then for 5.25, much, much less. And I remember using those too. That's how old I am. Okay. All right. I was pretty little though. Okay, and our last field to be added for this class is width. We just need to have it passed in. Is it a 3.5 inch or is it a 5.25, right? So we'll allow for that here and store that with it. And then we'll have our, actually, let me set up the constructor this way. And then we'll just adjust it. So we don't need to pass in disk type or spin rate or capacity. We only really need to create it with a name and a width. And then how we're going to handle it here is to say, pass the name along, but for disk type, we're going to call it floppy disk always. So we can just hard code that. Let's go ahead and set the spin rate and the capacities at 0 so that we can calculate them based on the width using these values up here. So because of that, I'm going to actually call the setter for width, which we haven't created yet. So let me do that. It's not going to let me do it until we create it. Let's do the getter and setter for width. Okay, and now I can set the width and pass it the width. And the reason I'm doing it this way instead of doing this, is because I want to customize this. I want to do other things besides just setting it. So I'm going to define all of that here and then just call it so that it'll run all of it at once. Okay. So we can certainly set it initially, but then we also need to validate it. So I'm going to add a note there that we need to validate because we have to write is valid first. And we haven't done that yet. Okay, let's keep moving downward. Of course, we know we need to override toString through inheritance. So we will do override methods, do toString and say, okay, give me everything that's coming from media. And then on top of that, I want to use my file list and say get formatted file list. And for my header, I just want to say files. It's pretty straightforward for something like this, right? We'll just have file names. Okay. And then after we've done that, we can get to our implementing our methods from our interfaces. So we'll do methods required by rewritable. And then down here, we'll do methods required by variable speed. We have two different sets that we need to implement. Not variable speed, variable RPM. Yeah, make sure it's the right name. Okay, so let's use this and say implement methods, and we'll go ahead and do the first 4 here. And then down here, we can do it again and grab the other 2. All right, and then we just need to define each of these. Okay, so we're going to actually do this really similarly to the way DVD was done. So I'm going to borrow from it here. And we'll just change the wording a little bit on this one. So where were we? Floppy disk, here we go. So we'll spin the disk, we'll check to see if the file is there, and if it's not, we'll say, the file's already been added. Otherwise, if the space is, if there's not enough capacity, we'll just say that. And then here, we can just say the file, file.getName has been added. And then, yeah, finish that off. Okay, so very similar, but it's not a video, it's just a file. For remove file, this one is also very straightforward. So I think we can borrow from this and there'll be very little that has to be edited. All right, we'll spin the disk so it can, print out that information. And then we'll just say if the file is present, remove the file, and then we'll just say it's been removed from. Yeah, we didn't actually need to edit that at all. Okay. And then for reformat, it's going to be very straightforward. It's going to be a classic spin the disk to get it up and running. And then if the file is present, oh, sorry. I'm looking at the wrong one. This is reformat. We don't have to do that. There we go. We just need to clear it. Get the file list and clear it. And then this one, we can just say, you know, if we're running the file, we're just going to say we're opening the file. So we can check for it, spin the disk, open it. And I want to say, let's see, did we over in these, did we add any sort of message there? We didn't. That's right. This is one of those cases where we don't need to have an else and then print a message that says the file isn't found, because we already accounted for that in the file class by, the media class, by saying, you know, that file does not exist. So that will print for us in the process of validating this. Okay. Just want to make sure. Okay. So we've got all the ones required by that interface done. Now we can come over and do is valid and calculate spin rate. So these are the ones that are new to us. And really, to say that something is valid here, what we're concerned with is making sure that we're going to be able to access these values, and that means that these keys have to exist. So the width that has been passed in needs to be one of those two values. So we're going to need to validate on that basis. So what we're going to return is that speeds contains the key width, and capacities contains the key width, which if one does, the other does, but this is, you know, the way to be absolutely clear, just in case you ever ended up at some point where, you know, they diverged for some reason, but they shouldn't. Okay, and then down here where we're calculating the spin rate, this is as simple for this one is just going to the speeds and saying, get the width, or get the RPM for this width. So if the width is 3.5, it'll go to speeds and it'll say, okay, the RPM is 300. Otherwise, it'll return 360. And you'll notice that I'm not doing any validation here, right? That's because this method, and this is something that can get really tricky when you're planning these kinds of things out. Like I did a lot of rearranging of things as it became more clear to me as I was working on this, because I realized this method has one job. It's meant to calculate this. That's all I'm going to do is provide that number. The validation takes place at the point at which you're deciding whether you're actually going to take some sort of action, not when you're calculating it. So that's where we need to go back up now to our to-do and say we're going to validate, and this is why we're customizing setting the width. We need to make sure that as we're setting the width, it is actually valid. And then we can say, you know, we might have set the spin rate at 0 and the capacity at 0, but once we've validated the width, we've set it and validated it, we can take care of that here. We can set them here. And the thing about that is, you know, you can end up in like this problematic circle where you're trying to like validate and set these without, I mean, you're trying to set these without having set the width yet. So we have to wait until we set it, then we can validate it and we can warn them and say, hey, you need to set a proper width again if it's not valid. But the only way to calculate it from the width is to set it first. So let's have one of those new lines in here, system.line separator. And then we're going to say if is valid. We'll set the spin rate and we're going to say calculate spin rate. And then we'll say set capacity and go to capacities. Oh, capacities and get width. And then we can print a confirmation and say new line plus spin rate and capacity updated for get name plus a period. Okay. However, if it's not valid, we're going to do something about that too. We're going to say something very specific. We'll say warning, spin rate and capacity not set. And then I'm going to put a new line in here. And on the next line, say, please set a valid width and tell them exactly what's valid. 5.25. Okay. And that should take care of, and then they can use the setter for this to set it again, and then it'll go through the motions again and just check to make sure that new one they've set is valid. So we're recycling this to make it possible for them to get it right if they get it wrong, and then make sure that these get set properly once it has been validated. All right. So that was really the most special thing about this one, I think. And so it's good, it's rewritable. It's got a variable RPM. We've got a lot of different behaviors going on here all in one class. And that's why it's so important to define those with interfaces and not through inheritance, because floppy disk has things that these other ones just don't in common together. All right, so we've done floppy disk. Let's do vinyl record. And then once we get done with that, we can go over here and do frisbee and wheel. So I'm going to create another class. Vinyl record. Extends media. It is media, but it's going to implement variable speed, now variable RPM. It does not implement rewritable. It is not rewritable. It's pressed. So, but it does have 3 different sizes and 3 different speeds. So this is where this other interface is going to give us some different behaviors that we're going to require be defined in this class. All right, so let's double check here. We need speeds, a map of speeds to look at for the different diameters. We need diameter, and we're going to add artist as well. All right. Start at the top, private, static, final. This is a constant. We'll make it a map of integers. Oops, wow, that is not what I was going for. And we'll call it speeds equals new hash map. And I'm going to do this like I did the others, where I use these double curly braces so that I can just execute these little methods here and say, for the integer 12, put the integer 33. So if it's 12 inches, then the RPM is 33. If it's 7 inches, we're going to assume it's 45. And if it's 10 inches, we're going to assume it's a 78. And again, I recognize that this is not hard and fast, but it's a generalization just for the sake of making this not terribly complicated. So we also need to allow for a diameter to be stored and an artist. So let's do a constructor that sets the diameter and the artist, but we'll customize it. We don't need to grab these 3. We're going to provide for them separately. So we'll just take name, diameter, and artist in, and then here we'll always set this type to be record. The spin rate we're going to initially set to 0 until we can calculate it here, and then the capacity is going to be 440. So another hard-coded number. Okay. Now artist we can do this way. That's fine. Diameter is where I need to actually, we're going to do this one a little bit like we did previously in floppy disk, where we set the width with its setter. Instead, we're going to do that here and set the diameter with its own setter. So put a little to do there until we're done. So let's create the getters and setters for these 2, and of course it was just warning us there that artist only has a getter because we said that it was final, and that's fine. So here again we're going to customize this to say, okay, set the diameter, and I can call this now that it's here, set diameter with diameter. we're going to say we're going to do more than this. We're going to check for validity. But there again, we haven't written is valid yet. So to do, validate. Okay. Validate and set spin rate is really what that should say. But let's see here. We've got a string, toString to override. Let's do that. We're going to call super.toString, and then we're going to add on artist plus new line. I need my new line, don't I? Let's do that. All right. And then after that, I'll add the formatted tracks with the header tracks, because this is a vinyl record and not like a floppy disk or whatever. So we've customized that. Now we can get to methods required by variable RPM. So I will use implement methods on the generator here and make sure I get both of those. And now we can customize them. So is valid, we are only concerned in making sure that the diameter that was passed in is one of these three, because if it's not one of these three, we're not going to be able to set the RPM. So we'll just say return speeds contains key diameter. And then down here, where we actually are calculating the speed rate, all we have to do is say, go and get the value for the key diameter. And then we can come back up here now and actually do this remaining validation similar to the way we did before. And go ahead and just say, if is valid, then set the spin rate, and we're going to give it calculate spin rate, and then print spin rate updated for, oops. All right, we'll get back in here. Get name and a period. And then here we'll say else. Let's see, warning, spin rate not updated for, and I'll kind of do the same thing, get name plus period. But then I can also say new line and tack on another sentence that says, please enter a valid record diameter, and put in parentheses, kind of like I did before, just to let them know, you know, this is what's actually valid. It has to be 7, 10, or 12. Or 12. And that way you're giving good feedback to let them know exactly what it was that they still need to do to make it work. All right, now new line has been defined, okay. And then you may remember that not only were we implementing these methods here, is valid and calculate spin rate, but vinyl record has a couple of its own instance methods. We want to press the vinyl. Again, this is kind of taking the place of what these three were getting from rewritable was, you know, writing files, running files. So instead we're pressing vinyl and we're going to play a track, and we're going to just define those differently. So we'll come down here and add these in. Instance methods, and say press vinyl. And again, this is going to accept a file array, an array of file objects. I'm going to do my new line thing. Yep. Okay. I'm going to keep track of the size as I'm going through. because we need to make sure before we press it that everything will actually fit. And so because this is an array, I'm using a classic loop here, just going by the length, and giving me something to use as an index, so I can use bracket notation to access each of the file objects. So total size is going to be increased by the file at index I dot get size. We're going to use the getter on that file object. And then once we have that total, we can say if total size is less than or equal to, and this is where we're going to access the capacity that we set up here. So we're going to say get capacity. Then we want collections, add all, and you may have seen me do this in lecture or in other things, but this is a really great way to dump the elements of an array into an array list. You just say add all, you say here's the array list I want you to add it to, and these are the files I want you to add from the array. So we use our getter to access that file array list that's defined in media. And then this file array that we've just passed in here has all those elements. We can dump it over. And then say vinyl pressed with all tracks for get name. Oops, not get capacity, get name. And then by, and we can add the artist name, why not? Okay, and then if it is out of capacity, you know, if it's too much, that's where we can say something else and just say plus warning, there is not enough room for all files to be pressed to vinyl on get name. Okay. So that will handle that process of saying I'm ready, I've got all my files and I'm ready to add them to the record. For playing tracks, we can have this play track and give it the name of the track that we want, which is, of course is a file object that we originally created. And we'll just say if file is present. It's going to be a lot like what we've done in some of the other ones. Spin disk. And then print. You are listening to, so the text is a little different, right? And then we'll say file.getName, so we can get the name of the actual file by, and then add the artist name. Cool. All right. So we now have floppy disks and vinyl records. We have established a second new interface, variable RPM, which is going to help us out, not just here with vinyl record, but it's going to help us out. Well, it helped us out with both of these, but also with wheel. When we get over here, we're going to use it for wheel as well. So let's go ahead though and go over to main and do a little bit of work to bear this out and create some objects and, you know, test some of these methods and things. Okay, so right here inside our main method, we're going to come and I'm going to paste this in. For our floppy disk and vinyl record classes, we will create a floppy disk. Let's say you're a student, you're writing some papers for your philosophy class. That's what you're storing on this disk. It's a 3.5-inch disk. And you also have a vinyl record, which is Magnificent City Instrumentals by RJD2. It's a 12-inch disc. And we'll create some files that we can place on these. So I'll have a history of philosophy paper and an absolute truths paper that are both, you know, doc files. They each have their own sizes. And then we'll write those one at a time using that method that was required by writable, the interface writable or rewritable, and set those on that floppy disk. And then here we can create these files: A Beautiful Mind, Fire, A Sunday Mystery, some of the tracks that are on that album. And we'll say that we're going to put them in an array and then use press vinyl to give it that array, and let it, make sure they're going to fit, and then press them on the vinyl and, make it possible for us then to listen. So then we'll print them just to see their two strings, all the information we have about each one. We can run a file from the floppy disk object and play a track from the vinyl record object. So let's give this a run and see the result in the thing here. Okay, so we are right here. Yep. Okay. So spin rate and capacity updated for philosophy papers, spin rate updated for, now the reason those ran was because, remember, we were calculating them after the fact. And so then it was printing, updating us that it was doing it, because we set that in motion through the constructor. So as soon as we instantiated those objects, it ran this code, and that's why we're seeing it here. So now we're trying to write things to the file. So it says, we're adding these docs to the philosophy papers. Here we are pressing the vinyl with all of the tracks for Magnificent City Instrumentals by RJD2. And then here we see the printout, right? Philosophy papers. It gives us all of the information that comes from through inheritance, and the list of files here. And then, of course, the same thing here, but we get a list of tracks, and it gives us that nice information. And then here we say, okay, we want to read the file, a file from the floppy disk. So it says opening absolutetruth.doc. And then we say we want to play a track from this album. So it says you are listening to A Beautiful Mind by RJD2. Okay, so we see, all of our customization kind of comes out as we test all of these out, and we see how each one is just a little bit different, and it fits, the type of object that we are using it with. All right, so that was bonus mission number 1. Now bonus mission number 2 is Wheels and Frisbee. They're not media, they're not data storage. They have other things, they're more physical. They move across, space, right? So we're going to look at this here, how we're going to have, use some of the measurements of them and add some specific instance methods, throw frisbee and drive car for the wheel. But we'll still have some of the same validation in place. Particularly, wheel is going to be required to have an is valid method because it allows for a variable RPM, and we're going to calculate the spin rate making use of that miles per hour that's provided. But you'll notice that miles per hour is not provided as part of the constructor. It's something that we're going to allow to be updated at any time using the setter. And then you can update it, and next time you drive the car, you'll be driving it at a different speed and therefore a different RPM. So we'll test some of that out. Let's head on over here, close this panel, and we will add more classes. So let's add wheel. All right, wheel is going to extend. Now, it's not going to extend media, it's just going to extend base disk. We're going to go right off of base disk. So we can have those fields and methods, but then add our own. So we'll start with private int radius. Oops, let me spell that right. There we go. Radius and private int miles per hour. And we're going to default this to 0. It's at rest until we actually start to drive. Let's see. I'm going to start. Actually, I'll just start with the generator, and we'll customize like we've been doing. We'll just be specific. Now, remember I said we weren't going to do miles per hour as part of the constructor. So I am going to leave that off. I'm just going to use radius. But like we have been doing in some other places, I'm not going to pass in a variable disk type and spin rate. I'm going to take care of it here when I pass it into the super constructor. So we'll say wheel, and then the spin rate, we're going to set at 0 because we're defaulting miles per hour to 0. And we won't update that until we actually change the miles per hour. So that takes care of that. We'll have getters and setters for both radius and miles per hour. But we're going to customize this one because we're going to need to validate and set, set RPM. Okay. But let's go ahead and set everything else up here. We'll do this, the toString. So I'm going to do an override on toString. We'll take the super toString. So we have all those rows of information and just add on 2 more rows. I am going to need my new line character. Yeah, there we go. Nope. Wait. There's already a new line at the end of this, so I only need to put it on my next one. So we'll say radius plus new line. Oh no. We have to actually have the radius in there, right? And I'm gonna say inches. And then we'll also have in quotes current miles per hour plus miles per hour. And we don't need to put the miles per hour on the other end of that because we already set it. And then we'll end it there, and I'll just get rid of this extra semicolon. There we go. Okay. So we've updated our toString to be specific for this class. Now we need to do methods required by variable RPM, because this is one of the ones that needs to implement that. So let's come up here and say implements, because we won't be able to use the generator until this is in place. Okay. Yeah, and now that we've done that, it's saying, okay, you better add those. So let's go do it. Implement methods. We want both of those. And in this case, our validation is different. We don't have any sort of constants up here, like storing specific values for us. This is going to be kind of fluid because it just really depends on the miles per hour. So all we need to say is we need to make sure that the radius is greater than 0 and the miles per hour is greater than or equal to 0, as long as it's non-negative, right? We just need to make sure we have real numbers to work with that are actually practical. That's all we care about. And then here we can calculate the spin rate, and all we have to do is say return math.round, and then miles per hour times, and this is where we're going to use that inches per mile that we're grabbing from the interface. And then we're going to divide the product of 2 times the radius times pi, which we also are pulling from the interface, times 60. Okay, and there again, because we made pi a float, math.round can round this to an integer, no problem. And it does in fact return an integer. Okay, so now we can come back up that we've got our validation and a way to calculate the spin rate. We can come back up and finish our custom setter on the miles per hour to handle that for us. So we're going to have a new line we need here. And then this dot miles per hour. Oh, I already did that part. Ha. I don't need to do that part again. Okay, we're just going to check and see if it's valid. So if is valid, that as defined in this class, it returns true, then we will set the spin rate with calculate spin rate, and we'll print new line plus MPH and spin rate have been updated for get name. Nope. Okay. But if it's not valid, we're going to print a warning. But we, our validation is spin rate was not updated for, and really, I feel like I should say MPH and spin rate were not updated for. Get name. Yeah, as I was saying, we're validating on two different things, and right now all we need to say is, hey, this wasn't done, but then we can also go a little further and give very specific feedback to the user depending on which one it was. So if we can say if the radius is less than or equal to 0. Actually, I think we said it had to be greater than 1, didn't we? How did we say that? Is valid greater than 0. Yeah. Let's do less than or equal to 0. If that's our problem, because the radius is too small, then we can say specifically, please set a radius greater than 0. And then we can also, independent of this, because it could be that both of these things are a problem. And if that's the case, we want both of these to run. So I'm not going to make them mutually exclusive. So we'll say if miles per hour is less than 0, if that's a problem, then we want another message here that says, please set a MPH of 0 or more. This can't be negative, and chances of them giving us a negative speed are pretty slim, but we're covering our bases. Okay. That's it. That should take care of it. The one thing that I just realized is that we should be running set miles per hour if the radius is updated. Just in case this was a problem, and that's where the validation took place. So I'm just going to do that. I'm just going to say when the radius is set, the radius is getting set here, but not through. So this would be only if they got it wrong and had to come back and do it. Then we would want to generate all of this again. So I'm just going to say, let's say, set miles per hour. And we'll just set it with the existing miles per hour just to run it. That's kind of a weak thing. I really feel like what would be better is to separate this out into a function and just call it from both places. But it's late and this has gone long, and so I'm going to leave it there. Okay, so we have now only things we have left are our instance methods. So instance, just one instance method, not plural. All right, this is where we're going to drive the car. All right. So if miles per hour is greater than 0, we can definitely go somewhere. So we'll spin the disk and say, you are traveling at, and then we can actually give them the miles per hour. MPH, please drive safely. And then if they are not at motion, we can say, you're not going anywhere and anywhere unless you set a miles per hour greater than 0. All right. Which would then it would push them to go back and use the setter to set the miles per hour. Okay, so we have everything good to go for wheel. Let's do frisbee and then we'll test them both out. Last one, guys. I know this has been long, but I wanted to actually this time go through the entire exercise. Bonus missions included. All right, do frisbee. Okay, so I stopped the video for a second because I realized that I needed to update this. I actually did intend for frisbee to also implement variable RPM. So we actually have four different classes here, 2 on this side and 2 on this side that are inheriting from variable RPM. And we're going to use these different diameters of the different types of frisbees to help us calculate what the RPM is going to be. So we can set the speed spin rate. So I updated the diagram and now we're going to continue developing this frisbee class and it will all work out. Okay, so we're going to take this and extend base disk because this is not a media type. And then we're going to implement variable RPM. All right, so now we have a number of things. First thing we'll do is put together our constants of diameters. Final, we're going to make it a map of string for key and float for value with our key value pairs. And that's going to be a new hash map. And I'm going to put those values in immediately and say put, if it's ultimate disk, make it 10.75 F for float. And then if it's a disc golf disk, we're going to make it 8.27 F. And then if it is freestyle, we want it to be 10 exactly. And that'll take care of those constants that we can refer to. For our constructor, we don't need to put the spin rate because we're going to calculate it. I'm going to set it to 0 for now. I'm also going to set disk type to null just for a minute while we're instantiating this thing. And then as soon as it exists, I'm going to call the setter, but I actually am going to override the setter. So you'll notice another thing I updated over here is set disk type is something I want to override. I can get that from the override methods and look and say, okay, of all the things available from base disk, one of them is the setter. That's what I want to override. And it automatically puts that override annotation on it. So it knows if I call it from here, it's going to use the one that's local. And this is the one that's going to actually call the one that's defined in base disk with super and pass it up. Instead of passing it up here, we're setting it at null instead. So that's going to allow me to run some extra stuff here, kind of like we've done before with other classes where we run a little bit of validation. So we'll pass it first to this one, and then we'll allow it to be set here. And of course I need my new line. Same all, same all. All right, and we'll say if is valid, set spin rate, calculate spin rate, and print a little something to the user. Spin rate has been updated for, we can say get name plus period. Okay. Otherwise, if it's not valid, we'll print new line plus warning. Spin rate was not updated for get name. And then have another sentence on the next line that says, please set a valid disk type. And we'll give them the specific information. It needs to either be ultimate disk, disk golf, disk, or freestyle disc. And that way they know exactly what they need to do differently. And then when they go to call set disk type and pass that in, we run through this again, it validates again, and it will set the spin rate accordingly. And so calculate spin rate is something that we need to override. So we're going to come, I'm curious about this in the, yeah, it comes from variable RPM, but we haven't defined it yet. So let's do our toString real fast. We're going to override toString. We're going to make use of super. And I'm going to just borrow this. How's that? But we're going to tack on another line that says diameter. So we can have this information as well. And this is where we go into diameters and get disk type, because the getter is actually in base disk plus new line. Oops, I think I did that. No, I did do that right. Okay, good. All right. Now, methods required by variable RPM. This is where we're going to implement methods. We'll get those two. And validation is going to take place on the basis of diameters containing the key from get disk type. So we'll say just return diameters contains key get disk type. Because remember, by the time we check is valid, we've just called super set disk type and set it. So it has it, even if it's not valid, it has it, and then we can actually check, and then we can say, okay, you need to do it again, and let them go around and fix it. So, but this gives us what we need in order to accomplish this validation up here. All right, and then the last one, of course, for these two is calculating the spin rate. And here's what we need to do. We're going to have average Frisbee mile per hour. We're going to do a little bit of fudging here because, again, the physics of Frisbees are something else. And then I'm just going to say we're going to go get the diameters using the disk type value. And then we can do the math. Math.round, average Frisbee miles per hour times inches per mile. Here we go again using this constant that's in the interface. And then we will divide by the diameter times pi from the interface times 60. All right. And then once that's done, it returns that that number, and we have our spin rate. And then up here, it will return it here and set it using the setter. Okay, last thing is our instance method. Void throw Frisbee. So, you know, we're going to call spin disk. This is really where this comes into play for something like this. And then have one last little fun thing that just says, hey, nice throw. And that's it. Okay, so let's go test these out. We are almost done here. We'll go over to main. I will, again, copy and paste this to save a little bit of time. And then we'll run it and see it at work. So again, make sure I'm inside my main method here. Okay. Bonus mission 2, wheel and Frisbee classes. So we'll create these objects. So I've got a Michelin and a Goodyear, 2 different types of tires. I set the name, I set the radius for each. I've got 2 different types of discs, an ultimate and a freestyle disc, and I gave them names and their disc type. I'm going to print each object. We'll see the results of that it is coming from their toString methods. We'll drive the car for one of those wheel objects. We're going to change the miles per hour for both wheels and then drive the car for both of them. Then we'll throw a disc for each of the Frisbee object and see what we get. So let's give it a run. All right, so we are here. The spin rate has been updated for the Innova Pulsar. The spin rate's been updated for the Discraft Sky Styler. So those are our two Frisbees. And then we have our printouts. We have all the information about our two different tires, our wheels. Current MPH is 0, which is what we expect because we haven't changed it yet. Then we have a little bit of information about each of our discs, and the Frisbees have very little information because they don't inherit from something like media that has keeps tacking on more and more of these additional fields. So these are a little shorter, but that's totally cool. And it says, you're not going anywhere unless you set an MPH greater than 0. So we tried to drive on one of these and it warns us, hey, you can't do that because you haven't given me an MPH. So now we're going to update those for both of the tires and then try driving. So now it says it's spinning at 420 RPM. So it calculated it for us. You're traveling at 45 miles per hour. Please drive safely. This one, it says is spinning at 784 RPM. You're traveling at 70 miles per hour. Please drive safely. Then we throw our Frisbees. This one is spinning at 1563 RPM and this one at 1681. Okay. So guys, this was big. This was a lot. This is a massive assignment. But I, wanted to take the time to do this very thoroughly to just introduce you to one of the lengthier kind of design processes of really thinking this through and trying to identify the differences between the types of things that can be passed through inheritance versus the kinds of things you want to put in an interface, because two things that are very, very different, may have some behaviors in common that we want to, standardize. So I hope this has been helpful. You guys know I love doing this stuff. Even though this one was long again, I wanted to do it justice this time around. So I hope it's been good, and I will see you in the next one.